AI.
More agentic capabilities.
An AI agent.
Agents.
Agentic workflows.
Agentic.
Alright, most explanations of AI agent is either too technical or too basic. This video is meant for people like myself. You have zero technical background, but you use AI tools regularly and you want to learn just enough about AI agent to see how it affects you. In this video, we will follow a simple 1, 2, 3 learning path by building on concepts you already understand like ChatGPT, and then moving on to AI workflow, and then finally AI agents. All the while using examples you will actually encounter in real life. And believe me when I tell you those intimidating terms you see everywhere like RAG or React, they are a lot simpler than you think. Let's get started. Kicking things off at a level 1, large language models. Popular AI chatbots like ChatGPT, Google Gemini, and Crowd are applications built on top of large language models, LLMs, and they are fantastic at generating and editing text. Here's a simple visualization. You, the human, provides an input and the LLM produces an output based on its training data. For example, if I were to ask ChatGPT to draft an email requesting a coffee chat, my prompt is the input and then the resulting email, the way more polite than I would ever be in real life, is the output. So far so good, right? Simple stuff. But what if I ask ChatGPT when my next coffee chat is? Even without seeing the response, both you and I know ChatGPT is gonna fail because it doesn't know that information. It doesn't have access to my calendar. This highlights two key traits of large language models. First, despite being trained on vast amount of data, they have limited knowledge of proprietary information like our personal information or internal company data. Second, large language models are passive. They wait for our prompt and then respond, right? Keep these two traits in mind moving forward. Moving to level 2, AI workflows. Let's build on our example. What if I, a human, told the LM every time I ask about a personal event, perform a search query and fetch data from the Google Calendar before providing a response? With this logic implemented, the next time I ask, when is my coffee chat with Elon Musk, I'll get the correct answer because the LLM will now first go into the Google Calendar to find that information. But here's what it gets tricky. What if my next follow-up question is, what will the weather be like that day? The LM will now fail to answer the query because the path we told the LM to follow is to always search my Google Calendar, which does not have the information about the weather. This is a fundamental trait of AI workflows. They can only follow predefined paths set by humans. And if you want to get technical, this path is also called control logic. Pushing my example further, what if I added more steps into the workflow by allowing the LM to access the weather via an API and then just for fun use a text to audio model to ask the answer, the weather forecast for seeing Elon Musk is sunny and the chance of being a good boy. Here's the thing, no matter how many steps we add, this is still just an AI workflow. Even if there were hundreds or thousands of steps, if a human is the decision maker, there is no agent involvement. Pro tip, Retrieval-Augmented generation or RAG is a fancy term that is thrown around a lot. In simple terms, RAG is a process that helps AI models look things up before they answer, like accessing my calendar or the weather service. Essentially, RAG is just a type of AI workflow. Here's a real-world example. Following Hena Hockey amazing tutorial, I created a simple AI workflow using make.com. Here, you can see that first I am using Google Sheet to do something. Specifically, I'm compiling links to news articles in a Google Sheet, and is the Google Sheet. Second, I am using Perplexity to summarize those new articles. Then using Cloud and then a prompt that I wrote, I am asking Cloud to draft a LinkedIn and Instagram post. Finally, I can schedule this to run automatically every day at 8 a.m. As you can see, this is an AI workflow because it follows a predefined path set by me. Step 1, you do this. Step 2, you do this. Step 3, you do this. And finally, remember to run daily at 8 a.m. One last thing, if I test this workflow and I don't like the final output of the LinkedIn post, for example, as you can see right here, it's not funny enough and I'm naturally hilarious, right? I would have to manually go back and rewrite the prompt for Claude. Okay, and this trial and error iteration is currently being done by me, a human. So keep that in mind moving forward. Alright, level 3, AI agents. Continuing the mark.com example, let's break down what I have been doing so far as the human decision maker with the goal of creating social media posts based on the news article. I need to do two things. First, reason or think about the best approach. I need to first compile the news article, then summarize them, then write the final post. Second, take action using tools. I need to find a link to those news articles in Google Sheets using Perplexity for real-time summarization and then Claude for copywriting. So, and this is the most important sentence in this entire video. The one massive change that has to happen in order for the AI workflow to become an AI agent is for me, the human decision maker, to be replaced by an LLM. In other words, the AI agent must reason. What's the most efficient way to compile news articles? Should I copy and paste each article into a Word document? No. It's probably easier to compile links to those articles and then use another tool to fetch the data. Yes, that makes more sense. The AI agent must act, aka do things via tools. Should I use Microsoft Word to compile links? No. Inserting links directly into rows is way more efficient. What about Excel? So the user has already connected the Google account with mark.com. So Google Sheet is a better option. Pro tip, because of this, the most common configuration for AI agent is the React framework. All agents must reason and act. So React sounds simple once we break it down, right? A third key trait of AI agent is their ability to iterate. Remember when I had to manually rewrite the prompt to make the LinkedIn post funnier? I, the human, probably need to repeat this iterative process a few times to get something I am happy with, right? An AI agent will be to do the same thing automatically. In our example, the AI agent would automatically add in another LM to critique its own output. Okay, I have drafted V1 of LinkedIn post. How to make sure it's good? Oh, I know. I'll add another step where an LM will critique the post based on the LinkedIn post practice, and let's repeat this until the best practice criteria are all met. After a few cycles of that, we have the final output that was hypothetical example. So let's move on to a real world agent example. Andrew is a prominent figure in AI, and he created this demo website that illustrates how an AI workflow works. I will link the full video down below. But when I search for a keyword like skier, enter an AI vision agent in the background is first reasoning what a skier looks like. A person on sky going really fast is in snow, for example, right? I am not sure. And then it's acting by looking at clips and video footage, trying to identify what it thinks a skier is, indexing that clip and then returning that clip to us, although might not feel impressive. Remember that an AI agent did all this instead of human reviewing the footage beforehand, manually identifying the skier and adding tags like sky, mountain, skies, snow. The programming is obviously a lot more technical and complicated than what we see in front end, but that's the point of the demo, right? The average user like myself wants a simple app that just works without me having to understand what's going on in the back end. Speaking of example, I am also building my very own basic AI using NAN. So let me know in the comments what type of AI agent would like me to make a tutorial on next. To wrap up here, here's a simple visualization of the three levels we covered today. Level 1, we provide an input and the LM respond with an output. Easy. Level 2, for AI workflows, we provide an input and tell the LM to follow a predefined path that may evolve in retrieving information from external tools. The key traits here is that the human programs a path for LM to follow. Level 3, the AI agent receives a goal and the LM performs reasoning to determine how best to achieve the goal. Take action using tools to produce an interim results. Observes the interim results and decides whether iterations are required and produces a final output that achieves the initial goal. The key trait here is that the LLM is a decision maker in the workflow. If you enjoyed this, hit that button and subscribe for more deep dives into the world of AI and creativity. Let's shape the future together. Thank you very much. See you.